exponential function exercise solutions. First up, we will evaluate the function f of x equals 4 to the 3x minus 1 at 2. So my input is going to be 2, which means I want to replace this x right here with a 2. So I'll have 4 raised to the 3 times 2 minus 1. Now for exponential functions, the exponent is in this imaginary set of parentheses, which says you need to do that 3 times 2 minus 1 first before you can take 4 and raise it to that power. And then we'll take 4 and multiply it to itself 5 times to get 1024. We'll plug in -1. So f at -1 will replace this x with the -1. That'll be 4 raised to the 3 times -1 minus 1. 3 times -1 is -3 minus 1 is -4. So we have 4 being raised to the -4 power, which says take 4 and multiply it to itself -4 times. But you can't do that. You can't do anything a negative amount of times. You can't clap your hands -4 times. You can't jump in the air -4 times. You can't take 4 and multiply it to itself -4 times. But from previous knowledge, we know we can get rid of that negative exponent by moving it to the other side of the fraction bar. So we'll move that down underneath the 1 to make it a positive exponent. And now we can take 4 and multiply it to itself +4 times, just in the denominator, to get 1 over 256. F at 1/2. Into my function, I'll have 4 raised to the 3 times 1/2 minus 1. 3 times 1/2 is 3/2, minus 1 gives me 1/2. And again, it's one of those, I don't know how to take 4 and multiply it to itself 1/2 time. But I do know from previous knowledge that raising to the 1/2 power is the same thing as taking the square root, and the square root of 4 is 2. Let's take a look at a graph. Let's see what the graph of g of x equals 1/3 to the x is. So I'll pick x values, plug them into g of x to get y values, take those ordered pairs and plug them. Now in this situation, you can pick whatever x values you want. But if you pick an x value that gives you a really, really big number or a really, really small number or a number that's not easy to work with, then choose another x value. So I started off by choosing 2. 1/3 squared is going to be, if you don't have addition or subtraction in the parentheses, you can distribute the exponent. So it's going to be 1 squared, which is 1, over 3 squared, which is 9. Plug in 1. 1/3 to the 1 power is just 1/3. Plug in 0. Anything to the 0 power is 1. Plug in -1. 1/3 to the -1 power. Again, I don't have addition or subtraction, so I can take 1 to the -1 and 3 to the -1. I can distribute that -1 exponent. To get rid of a negative exponent, you move it to the other side of the fraction bar. So this 1 will come down, and this 3 will come up. 3 to the 1 is 3, 1 to the 1 is 1, and 3 over 1 is 3. And then we'll plug in -2. 1/3 to the -2 power. I get 1 to the -2 power over 3 to the -2 power. Move them to the other side of the fraction bar. Bring this 3 up and this 1 down. And that gives me 3 squared over 1 squared, which is 9 over 1, or 9. So now I'm going to plot these ordered pairs right here onto my graph. So I've got 2, 1/9, 1, 1/3, 0, 1, -1, 3, and way up here would be 2, -9. Sorry, -2, +9. And then I can graph those with that nice curve, and that's what that exponential function looks like. Let's do some application problems of exponential functions. The sale for a company can be modeled by S of t equals 116.59 times 1.3295 raised to the t, where t is the number of years since 2001. Let's estimate the sales for 2016. So t is the number of years since 2001. You can pretend like t is your age, and this is the year you were born. So if you were born in 2001, and it's now 2016, and t is your age, you can find that age by subtracting 2016 from 2001, and you get that your age is 15, or that t is 15. So if I want to estimate the sales for 2016, into the sales function here, I will plug in t equals 15. And when I calculate that out, I get 8355.769042. But sales is represented in money, which is units have our dollars and cents. So we would say we estimate the sales to be $8,355.77. I would round up to that hundredth place right there. in 2016. Let's look at another one. The formula for continuous compounding is given by A equals PE to the RT. A is the future value of the account, how much you have in the future. P is the principal amount, how much you started with day one. E is that constant natural base we talked about. R is the interest rate. Just know that percents will need to be turned into a decimal. And if you don't remember how to do that, you take the percent and divide by 100, or you move the decimal place left 2 places. And T is the time. So if we're going to invest $1,000 into a savings account at 5.5% interest, how much money will we have in 2 years if we're compounding continuously? So we are going to use this A equals PE to the RT formula. We're looking for the future value, how much we're going to have. We know our principal amount, how much we start with today is 1,000. E is a constant that stays. R would be the interest rate 5.5%, which if I move this decimal place over 2 places to the left will be 0.055, and T will be 2 years. Go ahead and do this calculation in our calculator, and then we get 1116.27807. Future value of this account will be money, so we'll round to dollars and cents. And we'll say the account will contain about $1,116.28 after 2 years. That's it for now. See you next time.